Hello everyone, welcome to the class, our last class. Thank you for coming. Okay, so in this class we're going to talk about control charts for attributes. So let's first revisit the example we discussed last time. So this is a company who do the custom wallpapers and borders. Now, South of the Borders Inc. is a custom wallpaper and borders manufacturer. While their products vary in visual design, the manufacturing process for each of the products is similar. So each day, a sample of 100 rows of wallpapers is sampled, 100 rows every day. So the number of defective rows in the sample is noted. So the number of defective rows in samples from 25 consecutive days follows. So now what we need to do, we need to monitor the production process and how many non-conforming defective products every day. So we will construct and interpret the P chart. So before we move to the P chart, we know that this is the P chart, control limit. We have the P bar is the center line, and then we have upper and lower 1 standard deviation lines, upper lower 1 standard deviation lines, upper lower 2. This S stands for standard deviation. W is warning, and L is limit. So this is 2 standard deviation, upper and the lower upper and lower 2 standard deviation warning limit. And then this is 3 standard deviations. Then we call it control limit. You see here, this is 1 standard deviation, 2 standard deviation, 3 standard deviation. And then after we got a P bar, we can estimate the standard deviation. And then we use the P bar as our center line. Now this is the data, South of the Borders Inc. And every day, we have 100 rows, and this is the number of defective rows in day 1. And then what is the total number of defective rows? So we add this column together, we will be able to get the number of defective rows. So total of items sampled, 2,500. Total number of defective items, 196. So P bar, this is our P bar, and this is SP. So with P bar and SP, we will be able to derive the center line, and then 1 standard deviation above and below, 2 standard deviation lines above and below the center line, and also the control limit, 3 standard deviation below and above. Now, let's do the wallpaper together. So this is a wallpaper. So the first column is, you see here we have the first column. The first column, this is a number of days. This is a number of rows we sample in each day. So they are all 100. You see the sample size doesn't vary from day to day. They are all 100. And defective rows, and this is a PI. The fraction of defective rows. So 13 divided by 100, this is a fraction. Then based on the P bar is the sum of this row divided by sum of this column, divided by sum of this column. And so the total number of defectives, total number of items sampled. Then we got P bar. You see P bar is C29, this 196 divided by 2,500. And then SP, you see here, SP equals to this P bar, 1 minus P bar divided by 100, and then square root. Then once we have the P bar will be our center line. You see, this is our center line, P bar. And then we have, because we have standard deviation here, so we will be able to get the center line and then control limit. Control limit is a plus minus 3 standard deviation lines, and then plus minus 2 standard deviation lines, plus minus 1 standard deviation lines. Okay, so this will become our control chart. So in order to draw this control chart, you can just select this area, and then you insert the recommended chart. You see the chart is the first one. You just click, if I want to show it again, it's insert recommended charts, and then select the first one. You see, but up to this point, the chart is different from what it looks over here. How do we modify this chart? Okay, now I can make it bigger. You see, it doesn't look very good. So what we can do is we can just format the legend. You see here, if you move it right here, you can choose where you want to keep the legend. So right, so you can keep it here. And also you can change the line types. Once you select this line, and you can click this one, and then you can select the dash type. You can select this one, and this one, you can also select the dash line. And then you can do this for all of them. And if you don't like the chart title, you just double click, and then you can change the chart title. Now, there is another question, how to revise the legend. Okay, if you want to revise the legend, you need to select the data, and then click select the data. You see there's a name over here, series 1, series 2, series 3, 4, and 5. You click on edit. So here, the series name is empty. So you want give the, if the series name is empty, then automatically they will name it series 1, 2, 3, 4, 5. So if you want to give it a specific name, you may put maybe center line right here. You see here, it will become center line. You have one, this one, you selected it. This is the data. Okay, I didn't. Let's change it again. This is your data. Then you just put the data. And this one is your center line, and then you can change it to center line. Okay. So, okay, now we are, which one did I choose? Okay, then you can choose the particular series. Then you can add it, and then add the name. So this is how we create the control chart. Okay, you can collect data in the practice, and then do this control chart, monitor the process. And this is, I think, the skills we need to have after we get into the industry practice. Now let's continue. This is the first south of the borders example. Now let's look at the second one. So this one is called control chart for attributes, but this one is MP chart. We are not monitoring the fraction. We are monitoring the number of non-conforming. So MP, P is still the fraction. N is the number of units selected at random. That means the sample size. Okay? When you take a sample, what is the size of your sample? Okay? So D is the number of non-conforming. Okay? And P is the probability of selecting a non-conforming unit from the sample. So it's like we select X out of N, and this is a non-conforming, and this is conforming. So then we have the expectation and also the variance. Now, for MP chart, your center line is not P anymore. Now the center line is MP, number of non-conformatives. And then we have upper control limit, still plus minus 3 standard deviation, but this standard deviation is different from the previous one. The previous one is P, 1 minus P divided by N. But here we have MP 1 minus P. So now let's have a look at an Excel sample of MP chart. Let me see, I should have an MP chart right here. You see, this is an NP chart. Okay, this is a frozen orange juice concentrate. Okay, we're going to do a NP chart for the frozen orange juice concentrate. So this is a sample. Okay, sample size is 50. Okay, we're going to check number of non-conforming cans. So 50, 12 of them, they are non-conforming. And then second sample, 50, you take 50 cans, and then 15 of them are non-conforming. And these are all the PIs. This is a probability non-conforming for this sample. Okay. Now the sample size. You see here, we are always talking about the constant sample size, 50. But the sample size could be different. Okay. And later, we are going to talk about variable sample size. Now, this is a constant sample size, and we have PI. Now, we're going to monitor, instead of monitoring the fraction of non-conforming, PI, we're going to monitor the number of non-conforming. So for number of non-conforming, we need to have the first one we need to calculate is NP. Okay? NP. N is a number of. So now let's first calculate P bar. So this is P bar. So P bar is the average of this column. This is a this is a column of the probability to have a defect in each sample. Then we calculate the average. Then the center line will be the P bar, NP. So N times P bar will be B3 D38, B3 50. So this is actually center line is N50 times P bar, 23.13%. So 50 times P bar will equals to the center line. Then we will have the upper control limit. Upper control limit will be the NP plus 3 square root NP 1 minus P. Is it here? So this is my P bar. My sample size is N50. So 50 times P bar, this is this one. This is NP. And then plus 3 because why 3? 3 standard deviation lines. And then square root, this is NP 1 minus P. Make sense? Okay, so this is a plus, and then the next one will be the minus. If we look at this one, this will be the minus. So NP 3 square root NP 1 minus P. So this is a minus 3. Now we got the upper control limit and lower control limit and also the center line. So what I did here is I put a center line over here, 11.5667. And then I put a lower control limit, 2.6214 right here. And then 21.20 right here. This will be my upper control limit. Now, what we are interested at monitoring is the number of non-conforming. So this is a control chart. So we have the center line right here, center line 11.5667. And we have this data. This data is plotted of this column. Okay. We also have the upper control limit. Upper control limit is right here, and the lower control limit is right here. Okay. Now, if we want to, so here I have already created this plot. If we don't have this plot, how to create this one? So what we do is we actually collect this column, then we insert the line plot, like this line plot or this line plot. Okay, either one is okay. We collect this one. Now, this one only gives me the number of non-conforming cans. How to add this control limit? So in order to add the control limit, you just click the chart and then select data. Okay, And the first one is actually my data. So you just connect the data. And then you add another column, like this one. And what is the name of this, the one that we just selected? This will be the lower control limit. Okay? Now we add another column called center line. You see, once you add it, it will show up in the chart. This is the center line. We add it. You see here, it has already shown up. Okay? Now we add another one, upper control limit. Okay, this will be the upper control limit. Okay, it's done. We got the control chart. But this control chart doesn't have, again, very important. In the future, if you're going to draw a chart, a graph, you must have x-axis, y-axis, and also the title, and also the legend. Because you want to make this graph self-explainable, okay, and very clear to people. Okay. How to do that? You just click this one, axis title, chart title, and then you add the legend. You see, legend is right here. Okay, and then what is our x-axis? X-axis will be the sample number, right? And what will be the y-axis? What will be the y-axis? Christine? Oh.
Like your limits, your values?
Yeah, and in the y-axis we have the limits and also we have the data. But what we are focusing on is actually the data, right? We're trying to monitor the data. Then the y-axis will be very good.
Number of cans.
Number of non-conforming cans. Excellent. Because this will be the number of non-conforming cans. Okay? And some people would like to make it bold, and you just make it bold. Or if you want to make it italicized, you can make it italicized. And this is a sample number. And now you want to make sure people understand what is this chart. Then you say MP control chart for the number of non-conforming cans. Then people, they say, oh, you are the quality engineer, and then you have created this control chart, and you have the legend and showing me, oh, this is the data, and this is the upper control limit, this is a center line, this is a lower control limit. And if you are interested in changing the line style, you can do it all right here. Okay? If you don't like the color, you can change it to any color you want. Maybe purple. We have already got purple. Okay. So green. Was it already green? Okay. Then you can change the line style like this. So make it better, look better. Okay? And this is how we do the control chart. I think this is what you guys really need when you go for the job. And this is also the data analytics. Okay? Oh. And this will be one line. Okay, so this is the MP chart. Any questions when we do the MP chart? Am I making sense, folks? Clear? Okay, good. Any questions? Okay. Okay, this is the first two charts, and we have showed with Excel demos. Now we are going to move on to the next chart. Oh, before we move on, okay? Now, what did we observe from this control chart? Did you observe any out of control? Anything outside the control limit?
Some items are outside upper control.
This one, right? Okay. So you observe the control name, but which one? Which sample? It seems that we need to find out. Then you just click, and if you move cursor on this one, it will show up. It seems that it's data point 23, value is 24, and for this one is 15. That means if you do the production, the batch, sample 15 and 23 got problems. That means you need to figure out what's going on over there. Okay? Then if you observe out of control, what do you do? If you see, oh, this whole process, I'm the person who is in control, right? Who is in charge of this process. And suddenly it's out of control. And then what can we check? It's like a PDCA cycle. Plan, do, and then check, and then act. Okay, PDCA cycle. And you can check, okay, is this operator has some kind of, is he getting sleepy or something, and suddenly just didn't operate the machine very well? Or is it because of the raw material? This batch of raw material is supplied by maybe some of them, right? Then you find out the supplier maybe not very good. I need to reorder my product. And or you find out, okay, the machine setting that day was not well controlled. All the temperature that day is suddenly pretty high. Okay, it's like a steakage. Today you rain, and tomorrow you have like a very high temperature, right? So in some places, this could happen. So all this, they are called root causes. Root causes means you want to check what is the root cause that make you process out of control. Then you address the root cause. Okay? So why address the root cause? If you process out of control, why do you need to address them? Yeah, you want to solve problems, and you want to, because if you produce too many defective products, you are losing money because you cannot sell them, right? You're just wasting raw materials and all this kind of stuff. You always want to make your production process in control and produce the least amount of defectives, okay? So that you can increase your profit and the revenue, okay? You get a bigger paycheck, that's it. Okay, now let's move to the next one. So the next one is C and U chart for nonconformities. Okay, questions? Are we good? So when data originates from a Poisson process, it is customary to monitor output from the process with defect chart, or C chart. So Poisson process is the number of defectives in a piece of wafer. Okay. For example, you have car, right? You have dent on the car. So you see number of dents in this car and number of dents in that car. This could be Poisson distributed. And the Poisson distribution, we know that the mean is lambda, or here we use C. So mean is C and the variance is C. Okay? So if the mean is C, its variance is C, then it's so straightforward for us to do the control chart, because if I know the mean and standard deviation, it's just mean plus minus 3 standard deviation, plus minus 2 standard deviation, plus minus 1 standard deviation. If I can estimate this mean and the variance, of course I can establish the control chart. Now, how to estimate? So C represents the average number of defects or nonconformities per measured unit, with all units assumed to be of the same size, and all samples are assumed to have the same number of units. So M is 20 to 40 initial samples, and C bar is the number of defects in the M samples divided by M. Then this will be the estimated standard deviation. If you estimate the C bar, of course, square root of C bar is your estimate standard deviation. Because Poisson process, the mean and the variance are C, so standard deviation will be square root of C. But what we need to do is to estimate C bar. So once we estimate C bar, then the control limit is very straightforward. It's just plus minus 3 standard deviation, plus minus 2 standard deviation, and plus minus 1 standard deviation. Okay? Now let's have a look at this company. So this is a scientific technical materials company, and they produce materials for use as gaskets in scientific, medical, and engineering equipment. So scarred materials can adversely affect the ability of the material to fulfill its intended use. Okay? Now we are taking 40 pieces of material and taken at a rate of 1 per 25 pieces produced, given the results on the following slides. And using this information to construct and interpret the C chart. So this is the first piece. You have 4 scars. Second piece, you have 4 scars. And then in total, you have 40 pieces. And you see all the scars in each pieces. Now we need to monitor those scars so that we can see whether they are out of control or in control. So first one, we need to count how many scars in total. So how did we get 90? So 90 is actually this row, and this row, and this row. All the scars, you add them together. It's a number of scars. And then total pieces you have is 40. So that's why 90 by 40 is 2.25 is the center line. Now standard deviation is square root of C bar. Just square root of 2.25 is 1.5. And then we have plus minus 3 standard deviation, plus minus 2 standard deviation, plus minus 1 standard deviation. Then we got this control limit. But please note, why here, when we get this one is a negative value, this one is negative value, why we make it 0? Why we make it 0? And we could just use this, but we replaced it with 0. Why? Yeah?
We can't have a negative amount of scars.
Yeah, you cannot have negative number of scars because Poisson distribution is a number of scars or number of failures, right? So if we cannot have negative, so whenever we get the negative limit and we replace it with 0. Yeah, very good. So this is a control chart. Now let's have a look at how to produce this control chart. C chart, right? C chart is the materials. So this is C chart. I have already constructed this C chart. Now, what we need to do is, you see here, this is the data we have. So in this data, what is the first column? The pieces, right? You get one piece and you measure how many scars you have. This is sample 1, sample 2, sample 3. And in total you have how many pieces we have? 40? Yeah, we have 40 pieces. Now these are number of scars. Now let's first get a C bar. C bar equal to how to get C bar? Then equals to sum. Which column should we do the sum? Number of scars, this column. And then divide by how many pieces we have. How many pieces in total? 40, yeah, 40. So exactly this is what we got, 2.25. Then you have the center line, and then you have the upper control limit. Upper control limit is the C bar plus 3 square root of C bar. Because I have B47 over here. Where is B47? B47 is over here. It's 2.25. That's what we have already calculated, C bar. And the lower control limit, why is this 0? You see here, I have equation. This equation marks 0 or this value. If this value, if the lower control limit is greater than 0, then I will use that value. If it's lower than 0, I use the maximum one. So 0 or this value, the max one. So immediately by this equation, automatically I set it to be 0. Now, how to create this control chart? So what we do is you can. Previously we added one column by one column. Now you can select. You see here. You can select this all the data you want to plot: number of scars, lower control limit, center line, upper control limit. Now let's click Insert, Recommended Chart. You see the first one? Automatically, we got the control chart. But this is not exactly what we want. Some of you guys may prefer the legend. Okay? So if you're going to, you know what is legend? This is a legend. And where do you prefer your legend? You can prefer, some of you prefer to the left, some of you prefer to the right, some of you put it on top, some of you put it on bottom, right? So for the legend, if you want to fix the legend position, you just click Format Legend. You see here, you can put it on the top, you can put it on the bottom, you can put it on the left, you can put it on the right, or top right, okay? People has different preference, so that's why software allows us to do the selections, the options. And if you want to change the legend Series 2, what is the Series 2 or Series 1? Series 1 is a blue line. This is my data, so you can just add it. This is the scars. Number scars. Okay? You see, it becomes number of scars. And this Series 2 is the lower control limit. So you just put a lower control limit. And then Series 3 is the center line. Then you click Edit, center line. And Series 4, you can put upper control limit. And this will become your upper control limit. Then click OK. Now you got the legend. Now if you want to add the axis title, you can put axis title. Okay? Now this is your control chart. Now to this point, we can feel free to click on the chart like the axis titles. You can change them. So for this one, what is the x-axis? Yes, sample number, right? Still the sample number. Number, or sample index. What is the y-axis? Yes, number of scars. And this is what chart? What a chart are we doing right now? Yes, C control chart. For monitoring number scars per piece. Okay? So this will be the control chart. And what we have observed, so in this control chart, do we have anything out of control? Did you observe anything out of control? Yeah. And then you can click on this one, and you can move the cursor over here. You find, oh, this is 39. The piece 39 is out of control. So then you dig into the problem, see what's going on with this number 39. Okay. So an out of control at sample 39 is observed, where 9 scars appear on the surface of the sampled materials. So corrective measure would be identified and implemented. So after process stability was reassured, we could move into the PDCA cycle. Okay? So PDCA cycle. P, what is P? Wow, what kind of music. So P is plan. And then D, do. C, check. A, act. Okay. Okay, now previously we have the constant sample size, but the sample size may vary. You see here, if the number of defects in each sample, this sample actually we may have the sample size may be different from the second sample. This is sample 1, sample 2, sample N, but N1, N2, Nm, we assume they are constant, but they are not constant. Sometimes they are not constant. Then how do we deal with this scenario when it is not constant? So if it is not a constant, we call it a U chart. So U chart, still we estimate the U bar. U bar is all the defects and then total number of units in the M samples. Then you get a U bar. But when you monitor each sample, you actually divide by Ni. You don't divide by constant N anymore. So in this case, you will have a variable control limit. It's not a constant control limit anymore. Okay. So I think I have an example of variable sample size. Yeah, this is another one, variable sample size. Please note, here, control limit is not a constant anymore. Why it is not a constant? Because this is a sample number. This is a sample size. You see, previously we all have constant sample size, 50, 40, or 100. But now you have 100, 80, 80, and then you have 90. This often happens, okay, in the industry process because it's very hard for you to maintain the constant sample size. And the batch size may be different too. So that's why you sample. When you take the sample, you could take a different number of samples. And this is a number of non-conforming units. So what we do is, this one is actually monitoring the number of non-conforming purchase orders in a week. So we got a PI. So this PI is still this one divided by sample size. And then you got a P bar. Okay? And then based on the P bar, we can have the center line. Center line is my P bar, 0.096. And then now you see the standard deviation. The standard deviation is different. The standard deviation is P, 1 minus P divided by. Now, previously we divided by a constant sample size. Now you divide by B5. B5 is over here. That means you're going to divide by non-variable sample size. Just whatever sample size it is, you divide by that sample size. So you get a different standard deviation. So upper control center line doesn't change, but lower control limit is the PI minus 3 standard deviation. Upper is PI plus 3 standard deviation. So because of the standard deviation change due to the variable sample size, then we have the variable. We will have the variable control limit. You see here, this will be the max, still the max, because the fraction non-conforming. The minimum is 0. So this is center line minus 3E5. So E5 is right here. So the standard deviation. Standard deviation is not a constant, it's a variable because of the sample size is a variable. So, and also upper control limit plus. So what do we get? This is called a variable sample size and then control chart. Okay? So more flexible and more adaptive to the different sample size. So this is a U chart. Now there are 3 approaches for control chart with variable sample size. The one we just described is the variable with control limits. You can also do the control limits based on the average sample size. That means previously in the Excel spreadsheet, we actually used the actual sample size. And you can also do the average of all your sample size, and then use that calculated standard deviation. Then you still got a constant control limits. Or we can do a standardized control limit, control chart. Now let's talk about each one of them. So variable with control limits, this is equivalent to using a control chart for non-conformities per unit. And the control limits for each individual sample are based on a specific sample size. So based on the specific sample size. Okay? Now, based on the average, if we are going to, based on the average sample size, then this will be an approximate set of control limits. The average sample size is you have m samples, right? This is a sample size in each sample. Then you add all of them together, divided by m. This is an average sample size. Then you just use the average sample size. So the last one is standardized. Standardized means the points plotted is like standardization, x minus mu divided by sigma. So the points plotted are in terms of standard deviation units. So the standardized control limit has the following property: center line at 0, upper control limit 3, and lower control limit minus 3. The points plotted actually were given, this is zi, right? So it's every x minus the average divided by the standard deviation. This is normalization. What we discussed before in the central limit theory, CLT. Okay? We did normalization. We can also call it standardization. Now, in this control chart, we are plotting the standardized values. But the control limit is actually fixed. You don't need to calculate control limit anymore. So in the end, we talked about the variable control charts. That's X bar chart, X bar and R chart, X bar and S chart. Now we talk about different attribute control chart: P chart, NP chart, C chart, U chart, right? Okay. So and also variable sample size. Okay. Variables data can be more informative since specific information about the process mean and variance is obtained directly. And the variable control charts provide an indication of impending trouble. So corrective action may be taken before any defectives are produced. So attributes data are easy to connect, and several characteristics may be connected per unit. So attributes control chart will not react unless the process has already changed. Okay? So more non-conforming units may be produced. So this is the difference between how to choose the attribute control chart or variable control chart. Okay, so this is, I think I finished all the Excel demos in the course modules. X bar and R chart we finished last time. And here I have a video lecture on the Excel demos too. This is X bar, R chart, and a fraction non-conforming. If you missed some part, you can go and get it. So here, those are the details how to create the control chart. Okay, if you missed any specifics or you want to retrieve or review some of the details, you can go and watch this Excel demos, YouTube Excel, my video lectures. Okay, and so, okay, I think this is the end of the lecture for this semester. For the final exam, the exam 3, I have also posted the sample exam in the Canvas. So if you opt to take the exam 3, please, and work on those exam 3. And it has been a great semester with you guys. Okay, and I hope you guys have great finals. And also after this class, maybe next semester, if you guys have any questions, just feel free to stop by my office. You know where my office is. So Leonard 221. If you have any questions about the whole academic process and also where you are in the year, and or if you need anybody to discuss your academic plans, and come to see me. Okay, and yeah, have a good summer. I will see you next semester. Thank you.